at the time of ovulation, the follicle ceases production, well, it doesn't cease completely, but significantly decreases its production of estrogen, so that over the next few days, estrogen production starts to drop. It does not drop to zero. And at the same time, the very same follicle that extruded the egg and the other follicles which were maturing at the same time they switch over from estrogen production and they start making progesterone. Now I'm going to erase this part. I'll draw it back in a minute. Start making progesterone. What's going on in the endometrium? Well, let me tell you, folks. The endometrium really likes estrogen. And so, in this 14 days, the endometrium sees the estrogen circulating around and says, I really like this, and it starts to divide. Now, forgive me, I'm not going to draw each and every cell in there. I'm just drawing layers. Is that okay, please? Mm-hmm. And also, under the influence of estrogen, the arteries giving blood supply to the endometrium lengthen and start to twist. Now, at day 14, when estrogen production starts to drop again because ovulation occurred and progesterone starts to increase, something else happens to the lining of the uterus, something else happens to the endometrium. The endometrium likes estrogen. The endometrium loves progesterone. So under the influence of progesterone, the endometrium goes nuts. It divides like crazy. It gets thicker and thicker. And the blood vessels that provide nutrient get longer and twistier. Now, what happens to the resistance to flow in a blood vessel that as it lengthens and if it twists? What? The resistance increases. And because the resistance, because the resistance has increased, those vessels become very leaky, leaking a very significant amount of nutrient into this thick, lush endometrium. Oh. Let's go back to this picture. What happened here at day 14? Ovulation. Ovulation. The egg is extruded from the follicle. Here's the ovary. The egg is extruded on day 14. Now, assuming that the fimbriae reach up and cause the egg to enter the antrum, the egg is now going to start a journey down the fallopian tube. How's the egg going to get down the fallopian tube?
Peristalsis.
Streetcar?
Peristalsis.
Peristalsis. Peristalsis. Where's the egg going to get its nourishment? Well, the lining of the fallopian tube is cuboidal. It makes nourishing products, and it secretes them actively into the tubule. Additionally, the cuboidal cells that line the fallopian tube are highly ciliated, and the cilia wave and help push the little egg down. How long does it take for the egg to get from here to there? 6 days. It's a 6-day journey, plus or minus, but it's about a 6-day journey. Pretty fascinating. So,